My dear friends, welcome to Rajshekar classes on applied data science with Python. This is lecture number 407. In this lecture, we will try to understand code samples of decision trees. In scikit-learn, there is a very nice page called scikit-learn.org stable modules tree.html. So, if you just search for decision trees sklearn, you will get this page. This page explains decision trees very nicely. The diagram which we saw while learning decision tree regression. This page is very nice, which talks about advantages of decision trees. Just observe, there are advantages, simple to understand, requires little data preparation, the cost of using tree is logarithmic, able to handle both numerical and categorical data, able to handle multiple output problems, use white box models. There are so many advantages. Even if you observe, you can see disadvantages of decision tree. Decision tree disadvantage. Just to go through all these advantages and disadvantages of decision trees, the code is very simple and it is literally a one line of code. We just say CLF. Where is this CLF? Just let me just write. Just see CLF equal to tree dot decision tree classifier. Of course, we will import sklearn import. Just see from sklearn import tree. Import tree. Code sklearn is extremely simple. To move from one classifier to other classifier, just just we have to change the single line. Everything this line, everything else falls in place. There are a lot of examples here and nice code even for iris data set. If you want to visualize, a tree, you just have to import graph which. Just observe what is this graph which. Once if you install graph which, if you use this particular command here, it literally shows you tree diagrammatically. If you see for the iris data set, this type of visualization is very good. So it says petal length. Just observe this particular visualization. What it says, just see petal length is less than or equal to 2.45 centimeters. It's using Gini impurity here. What is Gini impurity? Gini impurity 0.6667. There are 150 samples. Just see how many samples there are. 150 sample, 50 samples of each class, isn't it? 50, 50, 50. There are 50 samples of each class. When the petal length is less than 2.45 centimeter, at this stage, just see, just observe it. At this stage, what happens? I have 50 points of setosa. Just see, here I have 50 sample size is 50. Here you have sample 100, isn't it? And I have points. What are the points here? You can observe here. 50 points of setosa flowers, isn't it? Setosa flowers, and I have no points of here. Here I have no points of versicolor and versinica, and my Gini impurity. Just see here, your Gini impurity is 0, isn't it? Which means, what is this node? This node is pure node. Gini impurity is 0. This node is pure node. So this node is already taken care. This node is already taken care, isn't it? Now let's look at this particular node. Just see this one. What is petal length is false. False means what? Petal length is not less than or equal to 2.45 centimeters, because we have false here. Just, isn't it? Here then it says petal. What is this? Petal width less than or equal to 1.75 centimeters. Here Gini impurity. What is the Gini impurity 0.5 here, and you can check here also. Petal length is greater less than or equal to 4.95 centimeter. Gini impurity 0.16. Samples 54. Well, just I request all of you just go through this particular structure. The maximum Gini impurity, if you see here it is 0.5, because you have two classes, especially just two classes, especially for two class case, you have two classes, which of them are equiparable. If you keep doing this, if you keep on doing this, if you keep doing this, suppose tree is being growing, so finally you reach a stage where, but here is a problem, you overfit here, because there is only one sample. Just observe this, just this notes, how many samples are there. Now, for example, just see here I have only one sample here, and one sample is what is this, Varzinica, isn't it? Here you have two samples. For example, here I have two samples, too few samples, too dangerous. Here is here too dangerous. Here you have 47 samples. If you observe here you have 47 samples, and it's good. 47 samples means I can say it's good. And here you have, again here you have one sample. Just see here you have one sample. This is also case of overfit. One sample means what? It's a case of, I can say it's a case of overfit. This is also case of two samples two. Again this is also case of overfit. This is samples one. This is also case of overfit. Here also you have case of, these are the dangerous cases. Only when you have enough samples, only when you have enough samples or sufficient number of samples, you can trust node. Otherwise, what if 1 point or 2 points or noisy points or outliers, your whole model, if you have 1 points or 2 points or noisy points or outliers, your whole model overfit, isn't it? So if you look at the decision tree classifier itself, this is the function. Just let's try to understand that classifier itself. Just see this one. Just see here these are these points which here you have only one sample, it overfits. Just see your two samples, three samples, one sample, two sample, one. All these points are too dangerous. They may overfit, isn't it? If they are outliers, it is too dangerous. Just see this. This is a function that we will use, and I told you the default criteria. This is a decision scalar.tree decision tree classifier. This is the function that we will use, and as I told you, the default criteria is often Gini impurity. Just see, we already discussed this Gini impurity. The default criteria is Gini impurity. The way it splits, the splitter. What is a splitter? Just see the splitter. Default is best, isn't it? Strategy is to choose the split at which node is Gini impurity. Information gain. Lot of software tools boxes use a scikit-learn. Pick a random sample. Just see, the strategy is to choose the split at each node. Support strategy are best to choose the best split, and random to choose the best random split. The default is best, but if I choose it to random, it will take one of the features F1, F2, F3, so on F100 randomly and split it. We will see why that it is useful and where that works and where that does not work. We will in next few lectures. When we learn in next few lectures, when we learn random forest. So the third most important feature here is obviously max underscore depth. Just see, this is max underscore depth. Default value is none, isn't it? The default value is none, and often useful to give maximum depth. If you don't give maximum depth, the default value is none, then it will keep growing the tree. Minimum underscore samples equal to split. Minimum underscore samples underscore split equal to 2. Just see, minimum underscore samples underscore split equal to 2. What does it mean? At a node, if there are at least 2 data points in a node, if there are at least 2 data points, it starts splitting. Anything more than 2, of course, this is too small. You need at least a bunch of points to be able to start splitting. The default value is 2. So oftentimes the best thing is to make your max underscore depth as hyperparameter and do cross validation search on it. The default min underscore sample underscore leaf is 1. What is this min underscore sample underscore leaf? This is 1, isn't it? Min underscore sample underscore leaf is 1. Of course, this is overfitting. Probably you can increase it. There are multiple ways to ensure that multiple ways to ensure that it is not overfit. One thing is to what you have to do. One thing is to reduce your max underscore depth. Don't keep it till you go wherever you want. Similarly, increase your min underscore samples underscore split, increase in min underscore samples underscore leaf. All these things will ensure that non-overfit. These all are very useful stuff that you don't overfit. Now there is other thing called max features. What is this? Max features, and very nice idea. So at any node, when you are trying to split, what we discussed till now, if I have D features f1 f2 so on, let me say I have D features. What does it mean? D features means what? Let me say my features are, what is that? Just let me show that one. Where is this one? Max underscore, just let me highlight max underscore features, isn't it? What is this max features? A very nice idea. So at any node, when you are trying to split, what we discussed till now, if I have D features, let me say I have D features f1 f2 so on, let me say fd it looks all D features. Instead of picking all the D, what it does is, or all the D features, instead of evaluating all the D features for information gain, what will it do? What will it do here? It could pick a subset of features randomly. A subset of features randomly. So typically, if we leave it as it is, max features is square root of, just see, max features is, what is the max features value? Just let me show. Your max features value is square root of n underscore features. That is basically D dimensions. Is it a square? I can say it is square root of D. Maximum number of features. Of course, you have class weight here. Especially, what is this class weight? Class weight for it is especially useful for what? Imbalanced data sets. For imbalanced data sets, you can give class weight to balance the data set, and as a result we get feature importance. As I told you earlier, sklearn after it learns your decision tree, for each feature it can give its feature importance. The importance of a feature is computed as total reduction of the criteria brought by that feature. In the case of classification, it will use information gain or reduction in entropy or reduction in H. In the case of regression, it will use reduction in mean square error. What about decision tree classifier, decision tree regressor? Decision tree regressor looks like similar to decision tree classifier, except for the criteria. Instead of using Gini impurity and entropy, we use a mean squared error. Just see here, criteria squared error. That is basically mean squared error, isn't it? Just go through this code samples and try to understand. If you have any difficulty, please keep a comment. Thank you very much.